Hey everyone, welcome to AI Deep Hallucination. Today's interview question is, what are the components of a complete AI agent architecture?
This one is tricky. Most people just list buzzwords, perception, reasoning, memory, tools, orchestration, and then freeze when the interviewer asks a follow-up.
Right, the interviewer doesn't want a list of nouns. They want to see how deeply you understand each component. Let's break it down layer by layer from textbook to production.
Let's start with the textbook answer first, then talk about what interviewers actually want to hear.
The textbook says 7 core components. Perception handles input. The reasoning engine is the brain. Memory splits into short-term, long-term, and episodic. Tool use connects to the outside world. Orchestration manages multi-step workflows. Multi-agent is optional collaboration. And finally, safety and governance.
Can you pass just by listing these 7?
You'll pass, but you won't stand out, because the interviewer will immediately ask, so should the reasoning engine use react or plan and execute? If you can only recite definitions, you're caught.
Hold on, I've memorized all these patterns cold. Are you saying that's not enough?
It's not useless, but you need to know what they actually look like in production. In practice, these are not independent complex architectures. They're all variants of the same while loop. In March 2026, Claude Code's 512,000 lines of source code leaked, giving us extremely rare first-hand evidence.
Huh? Wait, Claude Code, Cursor, Manus, Devin, all 4 have the same core architecture. Then, what's the difference between billions of dollars of engineering and a few lines of pseudocode?
Huge difference, but not in the loop itself. We covered this in detail in a previous episode. The core is just model call plus tool list, execute if there's a tool call, stop if there isn't loop. But 99% of those 512,000 lines are engineering around that loop. Permissions, error recovery, context management, cache optimization.
So what do academic terms like react and plan and execute actually correspond to in production?
React just adds an explicit thinking step to the while loop. Byte go put it directly when describing Cursor's architecture. One common way to implement this loop is the react pattern. Plan and execute in production isn't strictly plan first then execute either. Claude Code and Manus both use to-do files for soft planning, where planning and execution are interleaved.
So Anthropic themselves admit agents are actually simple?
Their exact words, agents can handle sophisticated tasks, but their implementation is often straightforward. They are typically just LLMs using tools based on environmental feedback in a loop. They even said the most successful implementations weren't using complex frameworks. Instead, they were building with simple, composable patterns. Bari Zhang added, complexity kills iteration speed.
But if you just say an agent is a while loop in an interview, won't that sound too simplistic? Won't the interviewer think you're being lazy?
No, because next you tell the interviewer the loop is simple, but what really determines an agent's quality is the engineering details, how you design tools, how you manage context, how you orchestrate. That's the iceberg below the surface.
Why does tool design rank first? Is it more important than model selection?
There's first-hand data. On SWBench, the upgraded Claude 3.5 Sonnet with just 2 tools, Bash and Edit, plus carefully optimized tool descriptions, hit 49%, which was soda at the time. Anthropic's own words, we believe that much more attention should go into designing tool interfaces for models, in the same way that a large amount of attention goes into designing tool interfaces for humans.
SOTA with just 2 tools? So it's not about having more tools, it's about having better ones?
Exactly, and too many tools actually hurt. Speakeasy ran a test. With 10 tools, a small model performed perfectly. At 20, it got 19 out of 20 right, just one mistake. But at 107, both large and small models started hallucinating and making frequent errors. It's not gradual degradation, it's a cliff.
GitHub Copilot confirmed this too, right?
Yes, Copilot trimmed their core tools from 40 down to 13, combined with smart routing, and saw a 2 to 5 percentage point improvement. Regular models are now around 80% on SWBench, but the insight that tool descriptions determine the performance ceiling still holds today.
How does Anthropic's ACI specifically guide tool design?
ACI stands for Agent-Computer Interface, an analogy to HCI, Human-Computer Interface. 5 core principles: less is more, don't wrap existing APIs, redesign for agents, namespace your tools, return semantic information instead of technical identifiers, optimize token efficiency, and make error messages actionable. We discussed related protocol-level issues in a previous episode on MCP versus CLI.
But in reality, users stuff hundreds of MCP tools into their agents. You can't stop them from installing tools, right?
Manus had an elegant solution. They don't delete tool definitions because that would invalidate the KV cache. Instead, they use logit masking at decode time to mask out tokens for unavailable tools. They deliberately use consistent prefixes for tool names. All browser tools start with browser underscore, so prefix prefilling can restrict the agent to a specific tool group.
That's elegant indeed. All right, we've covered tools thoroughly. What's next?
Context management. This is the hidden battleground of agent engineering.
Hidden battleground? Everyone talks about model capabilities, but hardly anyone discusses context management.
Which is exactly why it's a bonus point in interviews. Anthropic coined the term context engineering. Find the smallest possible set of high-signal tokens that maximize the likelihood of the desired outcome. All models suffer from context rot. The more tokens, the worse the model recalls information. The NOLIMA benchmark at ICML 2025 found that 11 out of 13 LLMs dropped to half their short context baseline at just 32K tokens.
We compared the two major schools of agent memory in a previous episode, right? Compaction and pruning.
Right, here's a key new finding. JetBrains presented at NeurIPS 2025, observation masking, which replaces old tool outputs with placeholders while keeping the reasoning history. Compared to not managing context at all, it was 52% cheaper and improved solve rates by 2.6%.
Wait, what about LLM summarization? Intuitively, summaries should be better since the model understands the content.
Counterintuitively, LLM summarization actually makes agents run 13 to 15% more steps. The summaries smooth out signals that should have triggered a stop, so the agent keeps spinning. The best approach is a hybrid, masking as the first line of defense with occasional LLM summaries as a fallback.
Claude Code now has a 1 million token context window. Does it still need compression?
Bigger window doesn't mean you don't need compression. Context rot is a structural problem. Claude Code still uses layered compression. First clear old tool outputs, then summarize conversations, keeping architectural decisions and unresolved bugs. Subagent isolation is also key. Each subagent works in an independent context and returns only 1 to 2,000 tokens of refined summary. The main conversation doesn't bloat at all.
All right, we've covered architecture components and engineering details. Interviewers also frequently ask about agent types. How do you answer without falling into traps?
This is the easiest question to get wrong. Classification lists vary wildly because people mix up different dimensions. Databricks said it directly. Some classify by decision behavior, some by system architecture, some by application role. Mix them together and the number of types just keeps growing.
So, in an interview, you should first clarify which dimension you're using to classify.
Exactly, that's the key. The most practical dimension is Anthropic's 3-tier orchestration. First tier is augmented LLM, which is an LLM plus retrieval tools and memory. Second tier is workflow, orchestrating multiple LLM calls through predefined code with 5 patterns. Third tier is the actual agent, where the LLM autonomously decides its own flow and tool usage. That's our while loop.
What about Russell and Norvig's classic 5 types? Reflex, model-based, goal-based, should you mention them?
Mention them briefly at the start to show you know the classic theory, then quickly pivot to the orchestration dimension. Modern LLM agents are naturally a hybrid of goal-based and learning agents, so the classic categories don't differentiate well.
What if the interviewer pushes further? How do different types of agents actually differ in engineering?
Backbone is identical. The differences show up in 3 configuration knobs. First is the toolset, the biggest differentiator. A coding agent uses file read-write and terminal. A customer service agent uses database queries and refund APIs. A research agent uses search and web scraping. Second is the system prompt. It's not just instructions, it's a permission system. VS Code's multi-agent system uses the same backbone, but plan mode is read-only and implementation mode has full editing rights. Third is the orchestration pattern. We discussed in a previous episode how single agents outperform multi-agent setups in most scenarios.
So to summarize, what's the core strategy for answering this in an interview?
5 progressive layers. Layer 1 give the overall framework. 7 components: perception, reasoning, memory, tools, orchestration, multi-agent collaboration, governance. Layer 2 reveal reality. Production agents are just a while loop plus tool calls. React and friends are academic labels, not independent architectures. Layer 3 go deep on tool design, cite ACI and SW bench data. This is the performance ceiling. Layer 4 show depth in context management, context rot, compression strategies, subagent isolation. Layer 5 nail the nature of agent types, same backbone, differences in toolset, system prompt, and orchestration, 3 configuration knobs.
Which layer counts as passing?
Layer 1 just means you memorize the textbook. Layer 3 and the interviewer feels you actually understand agents. Layer 5 and the interviewer might want to have a discussion with you instead.
Last thing, common pitfalls? I think the biggest trap is probably overhyping multi-agent systems.
You nailed it. 3 pitfalls. First, don't just list terms without explaining mechanisms. Second, don't confuse agents with chatbots. The core difference is autonomous looping and tool use. Third, exactly what you said, don't overhype multi-agent. Both Anthropic and OpenAI have explicitly said, maximize a single agent's capabilities before introducing additional agents. Got an interview question you want us to break down? Drop it in the comments. Hit subscribe and we'll see you next time.